looking at this, the first slide here, the first section that we're looking at today is on equivalent rational expressions. It's pretty short, yeah? Sure, yeah. Okay, it's on equivalent rational expressions. So a rational expression, does anyone know what a rational number is? I'm actually teaching a rational number unit right now for my grade 9s. Does anyone know what rational number means? You did do a whole unit on them in grade 9. Anyone? It is a number that ends. That's good. That's a pretty good definition. So it's a number that either terminates or repeats is usually is one definition that people give. And usually when we say rational number, what we're talking about is fractions. Okay, that's usually what we mean. So rational expressions, just like rational numbers usually mean fractions, rational expressions are fractions as well. So we're going to be looking at fractions, but that have polynomials as the numerator and denominator. So an example, like a really basic example of this is 1 over x. Okay, that would be a really, probably the most basic rational expression, 1 over x. Okay, so just it's basically a fraction that has an x somewhere in it, though. Okay, so you might get harder ones, like just slightly harder, like 1 over x minus 2. Okay, there we go, just slightly harder. Okay, you could have x over 3x plus 4. Okay, that would be one that you could potentially see. You could even get ones that are much longer, like x squared plus 3x minus 5 over x minus 2. Okay, that would be one. Okay, so anything that's a fraction that has an x somewhere in it is a rational expression. Actually, even a fraction without an x in it is technically a rational expression. So it's just a fraction, but most of the ones we're going to be seeing are going to have variables in them. Usually x, not always x, but we use x a lot. So is everyone okay with that? That's what we're going to be looking at this unit, is fractions with variables in them. This is a fun unit, right, Aurora? You're ready to go? Yeah. You look sad. No. Just lonely. Like, all our friends are gone. Okay. So non-permissible values is probably one of the biggest parts of this unit. On pretty much every question throughout the unit, you're going to be asked for non-permissible values. So I usually have at least a few students who never learn what one is and never understand what one is, and so they lose a point on every single question. So if a test has 20 points in the written response, they lose like 7 of them just off of not doing their non-permissible values. They're probably not going to pass the test, right? Like it becomes like a bad situation. So you need to know what a non-permissible value is. If we have 1 over x, that's the most, like I said, that's kind of the most basic rational expression. If you have 1 over x, does anyone know what number x is not allowed to be? 0. Okay, so some people remember it probably from 20-1. We've talked about it before. If you never took 20-1, it's just important for you to know that you're not allowed to divide by 0. Okay, on our calculator, if I try 1 divided by 0, I get a message that says error, divide by 0. You are not allowed to divide by 0 in math. So we have what we call non-permissible values, and basically all a non-permissible value is to look at the denominator and say what number would make the denominator 0. If the denominator is 0, we say that the expression is undefined. Okay, so that's bad. We don't want it to be undefined. Okay, so here, it's anything that makes the denominator 0. So if I look at this, try not to overthink it too much. It is a little confusing at first. Okay, if I look at this first one, x minus 7 over x minus 3, first of all, the important thing to remember is only the bottom matters with non-permissibles. The top doesn't matter. The top can be 0. You're allowed to have a 0 on the top in the numerator. You just can't have 1 down in the bottom. So all I care about is x minus 3. Okay, and what I'm thinking is what number, if I plug in for x, would make x minus 3 equal to 0. So what number would it be that if I plugged into x would make x minus 3 0? 3. So it's pretty obvious. So the way you actually technically do it, I mean, you could just look at it and tell it's 3, hopefully. But if you couldn't, you would just go x minus 3 equals 0. and you add 3 to both sides to get x equals 3. I think very few people would have to do that. Now, for non-permissibles, because we're not saying x is 3, we're saying x can't be 3. So you put a line through the equal sign, which means x cannot equal 3. And that's your non-permissible value. Okay, we're saying x can't be 3. If it was 3, we would have 0 on the bottom, and our fraction would be undefined. Okay, does that make sense to everybody? Okay, let's look at the next one. This is a little bit harder. On the bottom there, again, I don't care about the top. X minus 7 does not matter. 7 is not a non-permissible. X squared minus 9, if I'm looking at that, okay, x squared minus 9, that one's a little harder because there's more going on there. This is actually something that's called a difference of squares. So does anyone have an idea? What could I plug into x there that would make the bottom 0? Delaney? 3. 3 again. So 3 is an answer for a non-permissible, but it's not the only answer. Does anyone know the other number that I could plug in for x there that would also make the bottom 0? -3 would also work. Okay, so that is called a difference of squares. And it's something that you sort of just have to memorize. So, and we're going to do some factoring today. We're going to do a little bit of practicing. You're not going to have to do full factoring in this unit, but you will have to factor differences of squares. So x squared minus 9 factors to x plus 3 and x minus 3. So we have two different non-permissibles. We have -3 from that factor and +3 from this factor. And like I said, this one here, this technically I would factor this down at the bottom on this last one. You will never have to factor like this, but if you did factor like this, you would get x minus 3, x minus 1, and that means that there's two non-permissibles there as well. There's one for each factor. So for the factor on the left, what I say is, since it's x minus 3, I say that x cannot equal what? 3. So it's always the opposite, right? Like, if it's x minus 3, that means x can't be 3. If it was x plus 3, it would mean x couldn't be minus 3, -3. Okay, and then for x minus 1, my non-permissible is 1. And let's check that that actually works just for a second. So if I took x squared minus 4x plus 3, and I plug in 1 into it, I get 1 squared minus 4 times 1 plus 3, which is 1 minus 4 plus 3, which is 0. See, that's why it's non-permissible. If I put 1 into that equation on the bottom, I get 0. That's what makes it a non-permissible. And same thing if I did it with 3. I would get 3 squared minus 4 times 3 plus 3, which is 9 minus 12 plus 3, which is 0. Okay, so those are non-permissibles. But as I said, you won't have to do that factoring yourself. The only type of you're going to have to do two types of factoring in this unit. We're about to see both of them. But it's difference of squares and removing a common factor. Those are the only types. You're never going to have to factor trinomials. I don't know why, to be honest, but that's the way the curriculum is. So let's just be pleasantly, let's just be happy about it, because that type of factoring is hard. Okay, but it's weird because it's in 10C, then it's in 20-2, and then they don't have it in 30-2. But whatever, it's just strange, but fine. He really likes factoring, or very few people like factoring. Maybe somebody in this room love factoring? No. Usually if people decide after 20-1 they don't like it, it's because of all the factoring. So here, what we're looking at is writing a rational expression that's equivalent. So the reason here we're starting with this one, 8 over 12, is because you've seen this before. Can anyone come up with a fraction that's equivalent to 8 over 12? Anyone know one? Just yell it out if you know one. 2/3. Does anyone have another one? There's infinite number of them. 16 over 24 would also be one. Okay, we can keep coming up with them all day, right? Do people see how we did this? All I did is whoever gave me the 2/3 divided by 4. Whoa, that's crazy. They divided by 4 on both the top and the bottom. To get 16 over 24, they times by 2. Okay? As long as you're doing the same thing to the top as you are to the bottom, you're going to end up with an equivalent expression. Okay? So I could times the entire 8 over 12 by 7, and I would get an equivalent expression. Okay? But as long as I do it to the top and the bottom. Is everyone okay with that? Okay, that's like when you're younger, right? You had to do that. Now, you're particularly used to just simplifying, putting it into lowest terms, right? That's usually what your teachers would make you do. They'd say, oh, you wrote 8 out of 12, you should have written 2 out of 3, because you should have put it into lowest terms. And that is the case in this unit as well. You're going to be doing that a lot. But right now, we are looking at just equivalent expressions, not simplified expressions. So anything that's equivalent is fair. Now, if we're doing it with this one, which is longer and harder, obviously, and is something you've never seen before, 4x squared plus 8x over 4x. If I want to find an equivalent expression to it, all I need to make sure that I do is that I do the same thing to each term. Not just the top and the bottom, but to each term. So for instance, something that would work is multiplying everything by 2. So I could multiply 4x squared by 2, 8x by 2, and 4x by 2. I could multiply all 3 of those pieces by 2, and that would give me an equivalent expression. What else could I do that seems like pretty easy here?
Divide by 4.
Divide by 4, yeah. And even divide by 4x you could do. So let's look at both of those. Let's just look at them one at a time. So if I divided everything by 4, if I'm like, okay, I'm going to divide, I think I lost my stylus. If I'm going to divide everything by 4, that means everything. Okay, so what you have to do is follow the rules and do everything. So 4x squared divided by 4 would be what? Just x squared, or 1x squared. Okay, 8x divided by 4 would be 2x. Oh man, my stylus died, I think. It's just like last time. Such a tragedy. Okay. Okay, 2x. Still pretty bad. I think when it gets low batteries, it starts to like really suck. Okay, x squared over 2x, and on the bottom, 4x divided by 4 is x. So that would be an equivalent expression. I know it's really messy, but it says x squared plus 2x over x. Okay? Now, someone else, I think, said divide by 4x, which is also possible. We could divide everything by 4x. If I divided everything by 4x, what I would get is, does anyone know what 4x squared divided by 4x is? Just x. Okay, so just so you know, like some people probably aren't as comfortable with that sort of division as others are. What's happening there when you do that is you're dividing 4 by 4, which is 1, and x squared by x. So when you're dividing x squared by x, you're taking away 1x from the exponent. Okay, that's what's happening. It's a little confusing at first, but you'll get the hang of it, hopefully, if you practice enough. Okay, then we have 8x divided by 4x. What would that be? 2. 2 over 4x divided by 4x is 1. Okay, so that's like x plus 2 over 1. Okay, so these are both equivalent expressions. Okay, and x plus 2 over 1 is just x plus 2. That's something that I would like people to realize, that you probably wouldn't put the over 1. Okay, or I wouldn't put the over 1 if I was doing it. But you could. I wouldn't take off the points for it. I'm not mean like that. Okay, if you got this far, it'd be good. But these are possible answers. X squared plus 2, or x squared plus 2 over 1, and x squared plus 2x over x. Those are both possible answers. There's lots of other possible answers. Like you could double everything and get 8x squared plus 16x over 8x. Okay, you could, whatever. You could do lots of different things. The other way to think about it, if I notice that I got what I got at the beginning there, x squared Okay. If I got what I got there at the beginning where I got, how is this happening? X squared plus 2x over x, I think it was, right? Yeah. Okay, that's one of my equivalent expressions. One thing you can always think of doing too, and this helps some people and other people it doesn't help, I don't know, it kind of depends on your way of thinking. But one thing you can always think of is if they all have an x, I can take one x away from each of them. So if I take one x away from each of them, I'm like, well, that was x squared. So if I take one x away, I now just have one x. Here I had 2x. If I take the x away, I just have 2. And on the bottom, if I take the x away, I don't have anything there, so I just have a 1. Okay, that's another way of thinking about it. That as long as, and that only works really with x's and y's and stuff, but you can always think about it, as long as you do it to every single term, you're going to be getting an equivalent fraction. Okay? But that kind of stuff, we're going to be doing a lot of this where we're simplifying the fractions and looking at different ways of kind of looking at it. But I just like it if people just remember that as long as you do it to every single term, it's allowed. Okay? So let's look at factoring we need to do. Oh, no, not yet, I guess. I thought it was factoring, but not yet. We're not at factoring yet. Oh, we should be, though. These questions. And then we're going to have some time to just work on probability, or if you want to start this stuff, you could also start this stuff, but I'm thinking probability probably because we have our test tomorrow. So here, it wants the restrictions. Now, this one's pretty easy. Oh, restrictions, by the way, is just another way of saying non-permissible value. And guys, over there. Okay, non-permissible values, you're going to see it written as NPVs a lot, and that's, you know, usually the way I see students write it as well. But restriction just means non-permissible value. So here, for the first one, for A, remember, all I care about is the bottom. So the bottom is 4 minus x. If the bottom is 4 minus x, what can x not be? 4. It's that easy. Okay, because obviously 4 minus 4 is 0. Now, this other one requires factoring, which is why I wanted to do the factoring first. If I have x squared minus 5x, what can be factored out of that? What's a removable factor? X. So I should take out x, and then left in the brackets, I would have x minus 5. Now, with non-permissible values, what you have to understand is that each factor will have a non-permissible value with it, as long as there's an x in the factor. So here we have two factors. We have x and x minus 5. What that means is that we should have two non-permissible values. Does anyone have a guess at what one of them is? 5. Great. Okay, so 5 is one of them. That's the one that goes with x minus 5. Now, what about the other one? I've heard some people whispering it. Anyone brave enough to put it out there? It's the one that goes with this. And it's just 0. Okay? So if you have an x on its own, it's just 0. The reason for that is because, think about this. This means x times x minus 5. If I plug 0 in, if I go 0 times 0 minus 5, well, anything times 0 is 0. So that's 0. If I do 5 and I plug 5 in, I have 5 times 5 minus 5, which is 5 times 0, which is also 0. So both of those give me 0 on the bottom, which is what I don't want. Okay? So it's really, that one tricks people up. 0 is often a non-permissible. It's not always a non-permissible, though. I always get students who decide that it happens enough that they're going to put it with every single question. It doesn't, so please don't do that. But anytime you have an x that's factors out and is by itself, or is even with a number, even if you end up with something like 2x times x minus 5. Well, the non-permissible for 2x is still 0, because 2 times 0 is what? 0. What I see students do is they look at 2x and they think the non-permissible would be negative 2. It wouldn't be. 2 times negative 2 is -4. It's not 0. So you have to kind of be thinking about, try to think about it really logically. This stuff is confusing, undeniably, when you first start it. So we'll have lots of practice and do our best on it. But this is our just beginning part. Especially today, I know like a big chunk of the class has done -1. So hopefully it's vaguely familiar. If it's not vaguely familiar, don't worry, you can still get through this. I'm sure it wasn't a fun unit for the people who took it already. So we can do it. It is a tough unit though, so you really should be in class during it. I would say like it's not a good time to be missing a chunk of class. Like it's very hard to catch up on this stuff. And you also need to be actually practicing it. When we get to adding, subtracting, multiplying, dividing, they're really hard questions and you need to practice them. So you need to get through the work I give you. Okay. Here, I'm going to do this factoring first. I think it's kind of out of order, to be honest. So we're going to have to factor. These are the two types of factoring, like I said. There's two types. Okay, I'm going to do the first one of these with you guys. Actually, I'm going to do the second one in the first column, and then I'm going to let you do the other two. Okay, so the first type of factoring is removing a common factor. So that means you look at all the terms and you ask yourself, what can come out of this? What number divides into both terms? And are there any variables that I can remove? Okay, is there any variables that are in all the terms? So for 4x cubed and 6x squared, I would look at that, I'd say 4 and 6. What goes into both 4 and 6? 2. So I write the 2 out front. Okay, and then I ask myself, what about the x's? I have 3 x's in one term and I have 2 in the other. So what can I take away? 2 x's. You can only take away as many as the least has. You can't take away more than what one of them has. So I can take out 2 x's because that's the fewest that one of them has. And then I draw a bracket. And I think, okay, what do I have to multiply 2x squared by to get 4x cubed? So what would I have to multiply 2 by to get 4? 2. And what would I have to multiply x squared by to get x cubed? X. Okay? So there's already 2 x's. We want 3, so I just need to multiply by 1 more. That's the thinking that you should be doing. And then 2x squared to get 6x squared, I'd have to multiply it by 3. Okay, so that's that one factored. That's called factoring by removing a common factor. I'm just going to give you like 2 minutes. Try doing the other ones. Try doing the one above it and below it. So 18x squared plus 36x plus 42. Just remove a common factor from that. And then on the bottom, 6x squared y plus 10xy cubed. Try doing that one. Try doing these two. Hey, actually try doing them. Like, I'm sure some people are just sitting there not doing anything and are like, she's going to tell us the answers. And that's probably true. But it's much better for you to use your brain a little bit. It'll make you better at it in the long run. Some people never really learn how to do this, and then this unit is impossible. I'm going to give you 1 more minute. I'm sure some people are done. And it's okay if you got it wrong, and just write the right answer underneath afterwards. Okay, so the first one, what number divides into 18, 36, and 42? 6. So it should be 6. 2 also factors into them all, but 2 is not the highest. You always want to take out the largest number you possibly can. So it should be 6. Now, can I take out an x? No, why can't I take out an x here? Because 42 doesn't have one. If I tried to take an x from 42, I would not be able to. Just imagine it's like they're literally having these things and you're trying to remove them from them. If they don't have it to remove, you can't do it. Okay, so it's just going to be 6. Then in the brackets, it would be 3x squared plus 6x plus 7. Okay, sorry, it's a little messy. It's my stylus's fault. Okay, and that's it. Okay, now the bottom, 6 and 10, it's 2. X, and how many y's? 1. So you look at the x's and the y's separately. I'm sure some people were kind of confused by that. So I look at the x's, I have 2 in the first term, 1 in the second, so I can only take out 1. I have 1 y in the first one, 3 in the second, so I can only take out 1. And then I would have 3x, because I already have the y, and 5, what would go after the 5? Y squared. Okay, so I don't need an x, because I already have one, but I do need 2 y's. Okay, that's the thinking that has to go on here. You'll be doing a lot of that, so you'll get used to it. Now, difference of squares is also super easy, so it's awesome that it's the only type you have to do. Okay, and you don't have to do trinomials. You need to remember it, though. People forget it all the time. They get to these and they're like, I don't know what to do with this. And it's the only type of factoring you have to do. So please remember it when you see something like this. I can tell it's difference of squares because it's 1, a subtraction. That's what difference means. Difference means subtract. And 2, there's 2 perfect square numbers in it. Okay, so 25 is a perfect square number, and x squared is a perfect square number. Okay, any power with an exponent that's even, so like x squared, x to the power 4, x to the power 8, whatever, those are all perfect squares, as long as the exponent is even. Okay, so what you do is you draw 2 sets of brackets right away, because it's that easy. You just can get right to bracket drawing. And you think about, what's the square root of my first term? So here, my first term is x squared. What's the square root of x squared? X. So I put x there and there, okay, in the first part of the brackets. Then I think, okay, what's the square root of the other thing there, the 25? So I put 5 there, and one of them is plus, and one of them is minus. That's how you do this. So the factored form of x squared minus 25 is x plus 5, x minus 5. Okay, and that's it. Okay, so do the other 2 quickly here, and then I'll go over the answers. I'm only going to give you about 1 minute, because it really shouldn't take very long. Okay, so what will the second one be? X plus 1, x minus 1. Ooh, plus 1, x minus 1. They love that one, by the way. That one shows up all the time. So, just being really used to that. Now, this last one here is a little bit harder, but it's not significantly harder. It also won't show up much, I don't think. There's not very often where they show up like this, but you never know. So 16x squared, what would the square root of that be? 4x, so it's 4x and 4x. And then 81? 9, so it's 9 and 9. So it's plus 9 and minus 9. Okay, and that's it. So that type of factoring is very straightforward. I'd like everyone to know how to do it. Let's just use